This deep space photograph of the Andromeda Galaxy reveals a massive spiral structure, anchored by a bright central core. But consider a mechanical problem. What happens to this sweeping architecture if you completely remove its gravitational center? We see the answer in ultra-diffuse and irregular dwarf galaxies. Stars in these systems drift as disorganized clouds with no defined shape. Holding billions of stars together in a cohesive structure requires a singular, massive gravity source at the center. A galaxy's iconic shape and very existence depend on a massive, invisible engine pulling inward from its core. Over billions of years, a deep gravity well acts like a cosmic funnel. The fabric of space-time warps downward into a steep central valley. Gas, dust, and stars inevitably slide to the deepest point of this funnel, packing tighter and tighter together. The inward pressure compounds until physical matter can no longer support its own weight, collapsing into a supermassive black hole. This is Sagittarius A star. It is the supermassive black hole anchoring the Milky Way galaxy. This immense mass provides the structural foundation that an entire galaxy organizes itself around. All the matter dragged inward forms the nuclear stellar disk, creating the most densely crowded real estate in the known universe. In the spiral arms, our sun sits light years away from its nearest neighbor. Inside this core, millions of stars are crammed into that same volume of space. Right on the edge of this crowded disk is a zone known as Sagittarius C. Within this zone, immense gravitational pressure forces massive clouds of interstellar gas to rapidly collapse in violent events known as starbursts. During these events, hundreds of thousands of solar masses of newborn stars are forged at once. These young stars share their quarters with ancient dying remnants, creating a chaotic, multi-generational environment. The galactic center is the most aggressive, prolific stellar nursery in the Milky Way. Because the environment is so extreme, the galactic core serves as a natural laboratory for physics. The gravity near the supermassive black hole is intense enough to visibly stretch and warp spacetime. Astronomers and scientists track the rapid orbits of stars whipping around Sagittarius A star to test Albert Einstein's theory of general relativity. By measuring tiny anomalies in those high-speed orbits, researchers also hunt for the influence of dark matter dragging against the stars. Understanding the laws of the universe requires observing them closely where they are pushed to their absolute breaking point. In game theory, a Schelling point is a logical meeting place that people independently choose when they have no way to communicate. For any advanced civilization looking across the Milky Way, Sagittarius A star is that landmark, the only unique, universally visible focal point. Astronomers theorize that an extraterrestrial intelligence might place a messenger probe directly into this orbit to announce their existence. A probe locked in a retrograde orbit, moving against the spin of the black hole, would emit distinct artificial gravitational waves across the galaxy. Gravitational waves from the center travel through matter virtually undamped, serving as a superior broadcast mechanism compared to radio waves. The center is a gravitational anchor, a relentless stellar forge, a laboratory for physics, and a beacon in the dark.